Here we are trying to solve this Olympiad style exponential problem, and the first thing to note are the factors of the numbers involved. So here we have 13 squared to the power of x minus 13 to the power of x times 11 to the power of x, and that equals 11 to the power of 2x. And this can be treated as a quadratic in 13 to the power of x if we rearrange. And so we have a quadratic there in 13 to the power of x. And if we use the quadratic formula on it, it will give us 13 to the power of x in terms of 11 to the power of x. And this will enable us to solve the problem. And with the formula, we have 11 to the power of x plus or minus the square root of minus 11 to the x squared minus 4 times 11 to the power of 2x all over 2. And I can now clarify that. And we have 13 to the power of x is 11 to the x plus or minus the square root of 5 times 11 to the 2x all over 2. And so 13 to the power of x at the moment is 11 to the x plus or minus root 5 times 11 to the x all over 2, except that 11 to the x minus root 5 11 to the x will be a minus number, and 13 to the power of x cannot be a minus number. And here we have obtained 13 to the power of x in terms of 11 to the power of x, and so we're going to take the plus version. And so what that comes out to is 11 to the power of x times 1 plus root 5 all over 2 equals 13 to the power of x. And now we can use logarithms to solve this indicial equation. And so if we summarize, we can see that 13 upon 11 to the power of x will be equal to 1 plus root 5 over 2, because if I take this equation here, 1 plus root 5 over 2, and I divide both sides by 11 to the power of x, then using brackets, I get the version given there, and I'm now ready to try my logarithms. And so x ln 13 or 11 is ln 1 plus root 5 upon 2, and so x equals ln 1 plus root 5 upon 2 divided by ln 13 upon 11. And so x equals 2.880575 ...